the quadratic formula, in addition to the factoring, is another method that helps us to solve for x-intercepts or for our zeros. But the biggest thing is the quadratic formula can be used to solve any quadratic equation as long as it's in standard form. So the 8x squared plus bx plus c. Once something's in standard form, we just use one of our understandings from section 2. So that is to solve, find the roots, find the zeros. We're finding the x-intercepts. Well, if we're doing that, that means we have to set our y equal to 0. If it's already equal to 0, the form is correct. We're already set up for success. The hardest part is just going to be identifying each coefficient and obviously the constant. So being able to properly identify what is our a, what is our b, and what is our c. Then we just have to substitute it into this formula. My favorite, this is probably one of my favorite formulas because the actual formula can be sung to the tune of Pop Goes the Weasel. So if we cue the maestro, the way that you sing the song is it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And really catchy. I absolutely love it because yes, our x's will always equal the negative b, adding or subtracting, so plus or minus the square root of the b squared minus the 4ac all over 2a. So there's a few errors that usually go along with this formula, and I'll identify them as we go through this. So we're going to identify, or we're going to solve these two using the quadratic formula. The first one, we can absolutely use our products and sum and use just general factoring. If we were to factor this using all of our steps, it should come out, oh, 2 sets of brackets. It would come out as a 6x add 2 add 1. So if we factored everything, our answer should come out. Obviously, if we go further, this would put our x at a negative 1/6, and this would put our x at a negative 2. But our quadratic formula is used to solve for anything that's in quadratic formula, or sorry, in the standard form. The only thing is we just have to say, oh yeah, it's equal to 0. And then we identify what our a value is, our b value is, and what our c value is. So really nice and quick. Our a value is our 6. Our b value is 13. And our c value is 2. A value being in front of the x squared, the b value being in front of the x, and the c value being the number that doesn't have any variable. So we plug it into the formula. Our x would equal negative b. So this is usually one first thing, and we'll identify it better in the next example, but it always has to be the negative of the b value. Our b value is positive 13, so we're going to have to go negative 13. Plus or minus square root. Our b is 13. This is the second error that usually happens. People forget that you have to actually square a number. And when you square 13, it's going to have to be 13 squared. Again, I'll show that one a little bit nicer in the next one. This one's another common error. It's not being able to do multiplication correctly. It is 4 multiplied by a multiplied by c. So the a value is 6 and the c value is 2. The last error is that it is all over 2a. I've seen people just put just the part that's underneath the square root in. But of course, I will show you another fantastic way to make sure that you do not get this wrong. And the way that you do not get it wrong is you go one step at a time. Negative 13. Add or subtract. And we'll talk about exactly what that means. 13 squared. Well, 13 squared is 169. We're going to subtract 4 multiplied by 6 multiplied by 2. Well, 4 times 6 is 24, multiplied by 2 is 48. All being divided by 2a. So 2 times 6 is 12. As long as you show your work, you will not get it wrong. Well, obviously, you have to do the work correctly, but alrighty. Subtract 169, subtracting 48 is 121, all being divided by 12. Now the square root of 121 works out really nicely. It's 11. So it'll be negative 13. Add or subtract 11. Now just recently, I've seen this one as another error. For some reason, I've seen people who take the square root and then still write it as the square root of 11. No, the square root of 121 is 11. There's no more square root. So that's kind of a new error that I've seen. I haven't really seen it in previous years before. All right. So now we're going to get two answers here. And what I mean by that is with this adding, subtracting. This is the addition and subtraction, which means we have to both add 11 and subtract 11. So it's going to come out as two answers. We're going to have a negative 13 add 11 all over 12, as well as we're going to have a negative 13 subtract 11 all over 12. So it's going to come out as two separate answers. Negative 13 add 11 is negative 2. Divided by 12, reduced is negative 1/6. Negative 13 subtracting 11 is negative 24. All divided by 12 comes out as negative 2. Well, where do those two numbers look familiar? I've done the quick factoring, and our two answers are negative 1/6 and negative 2. I love leaving things as fractions. I expect that you're doing the same thing. Is negative 1/6 having it negative 0.1666666, right? Yeah, it just isn't clean. At the same time, writing negative 0.17, still not the greatest. So we're going to write down things as fractions. But these are our two answers, negative 1/6 and negative 2. So the next example comes in, or will help deal with a lot more of those errors, and I'll be able to point those out a little bit nicer. So first things first, we identify what our variables are. Oh, it's not in standard form. We don't have it as ax squared plus bx plus c. At the same time, we don't have one side equal to 0, which means we're going to have to do that. We're going to have to subtract the 7x over. Now, normally, we write it as our x squared first, then our x, then our constant term. It doesn't really matter which side equals 0. On this one, the 0 is on the left. This one, 0 is on the right. But what I need you to help identify is it doesn't matter. In form matter, absolutely. Writing things in descending order, it does. But when we're just going to be using formulas, it doesn't matter whether we write it like this or this. In the grand scheme of things. Of course, I for sure say that you should write it like this because it's just cleaner. But either way, identifying what our variables are, or not variables, the coefficients and constants, our number in front of our x squared is still our a. The number in front of our x is our b. It does not matter where it is in the equation. It's still b. And our constant term, number without a variable, is still going to be our c. So we have to make sure that we plug it into the formula correctly. So x being negative b, well, this one, our b value is negative 7. So we have to be careful. We have to have negative of -7. And I'll show in the next step that you can kind of bypass this, but you have to be careful. At the same time, you are squaring -7. Oh, sorry, I'll change that color. Subtracting 4. Yeah, this is the one. Our A and our C. This is the example that helps identify a lot more of these errors. 2A, which is 4. All right, so this first error, negative of -7. I understand that some of you will be able to understand that the negative of -7 is +7. That's great. You can do that. You can do that right away. This one comes a little bit stickier. If you plug into your calculator -7 squared, you will get -49. But if you do this properly, and you actually square -7, it's +49. -49 and +49 are so very different numbers. You have to know how to use, well, first off, you have to know how to use your exponents, which is grade 9, as well as you need to be able to use things properly in your formula. It is -7 squared. You have to do it properly. This next error, or sorry, next part of the equation that some people do is they don't know how to do this properly. So there's two ways of doing it. You can treat it as a -4 being multiplied by 4 being multiplied by -3. Well, 4 by 4 by 3 should be 48. Yeah. That's a +48. Or you can treat it as 4 being multiplied by 4 being multiplied by -3, which is -48. So depending on which one you do is the way that you have to put it in here. If you do it this way, it's going to be, sorry, I'm just going to move that second part down. You would have to be taking 49 and adding 48. If you do it this way, because we did not include this negative, that negative right there, in here, it would have to be 49 subtracting -48. Both of them, because subtracting a negative is adding a positive, both of them come out to be the exact same thing. But again, you have to know how to do your order of operations. If by a grade 11 you don't know how to do your order of operations, it's just going to be bad for you. Only my way, I personally like writing as subtracting the -48 because I like subtracting negatives. I know how to do it, so I'm going to do it. Again, making sure you take this entire numerator and dividing it by the entire 2 times 4, which is 8. So 7, add or subtract, say 49 subtracting -48 should be a +97. Double check that. Yep. Now the square root of 97, well, that's not really the nicest to do. We have to use our calculator. There's no number, 97 is not a perfect square, which means you could identify what is the square root of 97, and you could put that in part into our equation. So you could write it as 7 adding and subtracting, subtract the 9.8488 all over 8, or you could write it as 7. Well, sorry, add or subtract. I guess if we're doing it separately, we can do just the one at a time. Or my preferred method is I just write it like this. Either way is good. Because either way, we're still going to have to take 7 and add the square root of 97, which is 9.8488. So if we take those, add them together, you get 16.8488578 being divided by 8. But that answer has to be divided by 8. The entire numerator in every single one of these, this entire numerator is being divided by that denominator. You divide it by that denominator, you get 2.11. If you do it incorrectly, what some people get as an answer is 8.23. That is very different and very wrong. Again, you can write this in 2 different ways. So we're not adding, we're going to have to do the subtraction part. So either we write it like that, or we can write it like this. Either way is good, but it's still going to be 7 subtracting what the square root of 97 is. And this one comes out as negative 2.848857.802 being divided by 8. Personally, I like going things to 2 decimal places, especially for this one, for this section. Is a negative 0.36. So we have 2.11 and negative 0.36. What these mean, if we tie it back into our section 2, is if we plug these numbers into the original questions, they would come out as 0. So if I plug 2.11 and all the decimals into the x, multiplied by, or square it, multiplied by 4, subtracting 7, multiplied by 2.11, subtracting 3, it would equal 0. Same thing with that negative 0.356107225. They are zeros. They are the roots. They are the x-intercepts. They're our solutions. All right. A few more examples just to make sure that our skills are good. I'll just make sure I write down the formula again. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Really catchy. I love it. All right. Oh. Identify what our variables are. Not variables, our coefficients. A value is 4. The b value is negative 5. And the c value 6. Doesn't matter where they are in the equation. Those are our a, b, and c. So x would be negative b. So negative of negative 5. Add or subtract our b squared, which is negative 5, squared, subtracting 4, multiplied by our a value, multiplied by the c value. That entire thing is being divided by 2, multiplied by the a, which is 4. So keeping in mind what the common errors are, negative of negative 5 is positive 5. Add or subtract, negative 5 squared is positive 25. Now this one's a little bit different. Negative 4 multiplied by 4 multiplied by 6. So that comes out as 96. All divided by 8. 25 subtracting 96 is negative 71. Now, if we were to type in the square root of negative 71, we get an error. Sorry, I'll just start erasing this. You cannot take the square root of a negative number. Because you can't take the square root of a negative number, there's not going to be any solutions here. I will talk about what this entire thing really means in our next section when we do the graph. But all that we say is either we can leave it as an open bracket or open brace, or we can say this. There's no answer. And then we're all good. All right, last example, A, B, and C. Now there's two ways of doing this. Now 1/4, not that bad to use because it's 0.25. But what about if it was like 1/3? Well, you can't type enough 3s into your calculator to accurately put an A in for where you need to put the A's. So what we can do is we can use one of our foundations 10 skills. Get rid of our fractions. Multiply everything by the common denominator. I multiply this one by 4, I'm left with 1x squared. I multiply by this one by 4, I have a negative 12x. And this one is a positive 36. So now our A values, our B value, and our C value are just a little bit different. But it would still come out to be the exact same answer. One little bit of information. Again, these really are the exact same equation. Sorry, I did not say it, but 4 times by 0 is still 0. But these two are the exact same equation, which means that they would be graphing the exact same parabola. All right, let's go into the formula. Now I'll do one thing. We can do this one skip. Negative b. Well, since the b value is negative 12, negative b, the negative of negative 12 is positive 12. So by adding and subtracting, our b, which is still negative 12 squared, multiplied by 4, multiplied by our a, multiplied by our c. So I should change those numbers just into some colored versions. 12, 1, 36, all over 2a. So as we continue, we can evaluate what we can. So 12 plus or minus negative 12 squared being the 144. Subtracting 4 times by 1 multiplied by 36 is 144, if I'm doing my math in my head correctly. Yep. 2 times 1 is 2. 144 subtracting 144 is 0. Now this one comes out as another special situation because the square root of 0 is 0, and adding 0 or subtracting 0 is still going to be 0. We're just going to have the one answer of 12 divided by 2 because 12 adding 0 is 12 and 12 subtracting 0 is 12. So we actually come down to just only having one solution. And again, we'll talk about what that means when we start some graphs. All right, that means you should be able to have some fun.